So let's begin. Okay, so this is for your review. And I'll try to give you hints as well as to how to see it. Like this first one, okay? What you want to see here is that both of these numbers are perfect squares, right? 81. Remember, perfect squares are just numbers that you square. 2 times 2, 3 times 3, 4 times 4. If it's minus and they're both perfect squares, those are called difference of perfect squares. And it's always two parentheses, one of them is plus, one of them is minus, and you put the numbers there that multiply to those numbers. So 9 times 9 is 81, 4 times 4. A common mistake here is some students will put x squared, but you have to multiply back to that one. Yes, ma'am?
Does it matter if you put like 4x plus 9?
It does, because so the thing is that the ones in the front, these two, have to multiply to that one. And then these two, let me see the difference. That's a really good question. These two have to multiply to that one. So if you put the x with the 4, it won't give you that first one. If you do this mental check real quick of does that times that give me that, and this times this give me that, you're going to be right most of the time. Okay, so that's the answer right there, and nothing else. Now, one way I guess you could vary it, it could be minus plus instead of plus minus, but they just have to be opposite signs. Okay, question on that one, guys? No? Okay. Complete factorization. This one gets tricky. If you did this, you got 144, and so you would have got 3x and 3x. And to multiply to 144 and add to 24, it would have been 12 and 12, which is fine, no big deal right there, right? But then stuff starts happening because then you have to reduce. Like I can take out a 3 on this one. I'm just trying to think of how you guys did it. Maybe not, but that's how I think. The question is, do I keep that 3 or not keep that 3? What about that one? Can't I reduce that one as well? And the point is, it has to multiply. Again, this is where if you mental check real quick, it'll help you out. Like, does this give you this again, right? And it does. And does this give you that? And it does, okay? But here's a catch. This one's kind of tricky because they do say complete. If you read over here, it says complete. You got to reduce it all the way as much as you can. So on this one, you can take out a 3 again. Sorry, 3. But this time, you keep the 3. And that's really confusing, okay? Why do I keep the 3 here, but not here? Like, why? Okay, and I admit that's really confusing. The whole reason this is happening and it's getting so messy and like why here and not here is because we forgot to do something in the beginning, right? What could I have done first before doing all this? GCF. Okay, you should always try to GCF. If not, if you don't GCF, that's what happens. So I wanted to show you what happens if you forget to GCF. And so what happens is if you take out a 3 in the very beginning, then it greatly simplifies this problem. 8. 3 times 16 is 48, all right? That's good. Okay, and now it's an easy problem to do. A lot easier to work with. It's not funky. Here it's a lot easier to tell as well whether you should keep the 3 or not keep the 3. Because remember, it has to multiply back to 3x squared. So if I don't keep that 3 there, there's no way you're going to get back to 3x squared. So that 3 does go there. Okay. By the way, when we have two binomials that are exactly the same, we usually write it like this. Oops. Because we have two of the same things. Okay, because on tests like this, they want you to know like the most best answer, not just the right answer. We good on that one, guys? Okay, please ask me, okay, if something don't make sense. This one, if you have issues with this one, the students that have come in for tutorials, 100% of the time, it's the signs. Okay, so look at your paper. If your signs are wrong, we can fix it. but that's a one-on-one. I need you to come in so I can help you fix that, okay? Sometimes they'll put negative positive instead of positive negative, so be careful with those signs. Come for help, okay? Number 4, this is a GCF problem. One of the signs that you can tell it's a GCF problem is the big powers. Okay, you have these big old powers. And so this is, you're going to shrink it down with the greatest common factor. Like, first of all, what number divides into all those numbers? 6. Okay, 2 does go into those, but you want to pick the biggest number. 6 is the biggest number. And so 36 divided by 6 is 6. 24 divided by 6 is 4. And 6 divided by 6 is 1. Now you also have to take out the number of x's. Okay, and once again, the rule is you have to take out the most x's that you can, but it has to be the same amount of number from each term, right? So what's that magic number for this one? 2 of them, right? So I can take 2 x's out from each one. So if I have 10 and I take 2, that leaves 8. If I have 5 and I take 2, that leaves 3. And if I had 2 and I take both of those 2's, bless you, I have no more x. So this and only this is your answer. Okay, there's no other answer to that. Okay, GCF. This is a GCF problem. And this is quiz 1.1, 1.2. Those 4. Okay, which by the way I corrected it. It should be good now. I know I was putting 100 for how many attempts you guys had to try. I put 100 instead of the grade 100. Okay. Number 5, intercepts. So y-intercepts, x-intercepts. So here's your 2 x-intercepts. So x-intercepts are located at 2, 0, and 4, 0. The only mistake I see there is students flipping the x and the y. So watch your paper, make sure you didn't put 0, 2, 0, 4. If that's you have them backwards. Okay. Y-intercept, students today in my class have struggled with this question. We'd have gone over it, but everybody forgot because we didn't do it a lot. So it's not a guesstimate, it's we can actually figure this number out. Who remembers what all the points on the y have in common? Anybody? X is 0. Any point you pick on the y-axis, x is always 0. Why does that matter? Because if you plug in a 0 here and a 0 there, you can figure out your y-intercept, even though you can't see it. What's 0 squared? 0, 0 times 0, 0. What's 6 times 0? What's 0 minus 0? Only numbers left. There's your y-intercept. Which this graph is kind of deceiving. It doesn't look like it's going to touch at 8, but it does. Okay, line of symmetry, guys. This would be y-axis symmetry, but that's not what they're talking about. They're not asking. But it is y-axis symmetry. They're asking about the equation. We should have wrote here what's the equation of the line of symmetry. And it's pretty simple. It's just when you draw that line, you ask yourself, what axis did I draw it through, right? It crosses the x-axis, so it's going to be x equal to the number it crossed. So it crossed right at 3. So there's your line of symmetry. If it was sideways and crossed the y, it would be y equals. Okay, any questions so far? Okay, extrema refers to minimum, maximum, absolute, relative. Okay, so on this one, the only thing, bless you, that we have is this one, and it's a what, guys?
It's 3 negative 2.
3 negative 2, and what's it called? Absolute minimum. Is the most lowest part of the graph. Okay, that's what we mean by absolute. If it was the low one, but not the lowest one, maybe this will help too. Let's draw this little picture. Let's see. I don't know. Oh, that's a good picture. This is the highest point, though. That's the absolute max. This is a high point, but it's not the highest point. That's a relative max. It's a high point, but not the highest point. This right here is the lowest point, so that's the absolute minimum. And then these two would be relative minimums because they're low points but not the lowest point. Okay. The difference between absolute and relative. Remember, infinities we don't count. Okay, infinities don't count. On these, if you don't see like a solid dot or open dot, assume they go on forever. Okay, and then domain and range. Domain for this one would be all real numbers. It goes forever to the left, forever to the right. Range will be from -2 to infinity. I'm kind of biased because that's the form that I like, so I always kind of do that one. And I need to fix that because they could ask you the other form. The other form is like this. Y is greater than or equal to -2. That's the same as this. So you have to know how to write it both ways. Any questions, ladies, gentlemen? No? Okay, let's keep going. Number 6, is this increasing or decreasing? Decreasing, it's going down. The common mistake on this one is we read it on the Y, but we don't read it on the Y. We read it from the X point of view, right? So it's decreasing not from 4, from 0, all the way not to negative infinity, but that way, which is positive infinity. Okay, so very important. Maybe these are kind of like your notes, right? Read from x-axis. That's the point. You read it from the x-axis, not from the y. Okay, identify domain and range. It's a pretty simple one here. Domain, again, it's all real numbers, or negative infinity to positive infinity. Range is the same as the other one. -2 to infinity, or y greater than or equal to -2. Equal to because it's a solid line. Okay, x-intercepts, y-intercepts. X-intercepts, 3 of them. Again, just check your numbers that you don't have them flipped. Like you didn't put 0, -3, it's -3, 0. These are your x-intercepts. You have a 1, 0, 2, 0, right? And then you have one y-intercept located at 0, 6. Not 6, 0. Okay, 0, 6. Also, let's add it to this one. This would be a what extrema? Not absolute, relative. And that's a good point. Why I said not absolute? Because this still goes higher over here. Like if it's a roller coaster, I could still go higher, right? And then this one would be a relative minimum. Yeah. It just means relatively speaking, like comparatively speaking. That one's low, but not the lowest. Okay, I thought of a new way of teaching this to you today as I was teaching. How to come up with the parent functions even without memorizing them, okay? Just erase all the movements, like erase all the transformations, take away all the ups and downs, the lefts and rights, the reflections, the stretches, the compresses. Erase all that. There's my left movement, there's my horizontal compress and stretch, there's my reflection. Take away all the transformations, and that's your parent function. Been teaching for a long time and I just thought of that. So. Okay. Let me stop just for, well, do you want to keep going? You want me to keep going or you want me to give you a little bit more time?
Keep going.
Keep going? Everybody? Yeah? Okay, but ask if you don't know. Here, let's kind of work together. What does this +1 do? Up 1. Yeah, up or down, but it sends positive up. And then the +2? Left. What about that 4 right there? The negative does.
Vertical stretch.
A reflection over the x, but this one is a vertical stretch. So you got to think of the negative separate from the number, right? The negative is a reflection on the x, but the 4. Now let's be more specific in case they get more specific with us. Is this by a factor, vertical stretch by a factor of 4 or 1/4? So it goes back to normal and opposite behavior, right? Where does the opposite behavior happen?
Inside the
Inside. So since it's outside is normal, so you just read it as cis. If the 4 was inside the parentheses, then that's opposite. Then we would say by 1/4, because it's opposite. Okay. Tricky, but once you know that, it gets easier. Okay, on my other class, I asked him about this one, and we had very low confidence about number 11. Like nobody knew how to answer that. And so here's my hint to you, okay? If you do this, what appears to be a difficult problem becomes a very simple problem. Sketch it. That's all you have to do, sketch it. Watch. Vertical wall, asymptote. Here, vertical is like this. So I'll put a wall at -4. Wall. Horizontal wall, horizontal asymptote at y equals 1. So I put a wall at y equals 1. Right? Everybody here can do that, right? Once you do that, then all you have to figure out is how did you go from the origin to that spot? And so we went left 4, up 1, right? And so now we put it into this. Now this one is the weird one, okay? Because this one's the one where you move on the bottom. So left 4, that's your left 4. And your up one's the same as the other one's, up 1. But if you draw the walls, the asymptotes, then it's really easier, a lot easier to come up with this equation. That makes sense, guys? Okie dokie. Let's come up with this one. So y equals something squared. Okay. I left big spots, holes, so I can put the numbers where they go. So the first number says vertical shifted down 3. -3. Okay, that's all that means, -3. Phase shifted right 4. On the inside, right? Nope. Yeah, right 4, -4, sorry. In the inside. Now, look at this one. If you see the word vertically, it doesn't matter if it says stretches or compresses. The fact that it says vertically automatically goes out here. It doesn't even matter what it's doing. A goes there. And that'll be it. That's all they said. Okay, that's your equation. We'll come back to that one. Let's do this one real quick. Where's 2 true on this one? Top or bottom? Top. Okay. 2 is less than or equal to 2. 2 is equal to 2. So we don't do that one. Okay. We plug in the 2 in there. And this one's easier than the ones that we were doing in class because we were plugging in negative numbers. This one's a positive number. So it's a low risk. It's hard to mess that up. Okay. 2 squared is 4. -2 times 4 is -8. -8 minus 1 is -9. The only thing I've seen wrong with these is plugging in the wrong equation. So just be careful which one's true. Remember, even if you had 4 different equations, it can only be true for one of them. Okay. We're good about this one, guys? Any question? Okay. All right, here, who's the baby, G or F? G. Okay, so G is going to go inside F. So this will go inside here. Okay, so here's how it looks. -4 times something plus 1. That's the mom, that's F. So I put G inside there. G is 2x minus 7. Anthony, that's you miss it. That's called compositions. It's just embedding an equation inside of another equation. Okay. Once you do that, you just finish it off by simplifying. Okay, so -8x. What's -4 times -7? Positive 28 plus 1. The only thing you can add there are the numbers. Okay, so -8x, the constants that have no x. That's it. That's all you can do. Okay. If you went backwards, if you plugged in, it would give you a different answer. Okay, so you have to be very careful who's the baby, who's the mom. Question on that one. It's really important that you ask, because remember the disadvantage of the review is there's only one of each kind. Right? There's only one of this type, one of these type. Okay, we didn't practice these much, but here you're adding. Does order matter when you're adding? No, but we'll still follow the same order. 8x minus 3 plus 3x plus 1. I taught like terms in Algebra 1 with freshmen. I would have them get highlighters and do this, like put the same shape on the like terms. I don't know, if you struggle with that, it might help. Okay, the ones that go together, add together. So x's add with x's, numbers add with numbers. Okay, this one reads like this. Y equals 3x minus 2. Now, you're not going to be provided the steps, but what are the two steps to find inverse? That's for sure in your mind. What's the first step? We switch the x and the y. So this is not called switching the x and the y. That is the y. So I didn't switch nothing there. If I switch them, it looks like this. The x becomes y, the y becomes x. That's step 1. What's step 2? Yes, solve for y. Okay, those are the two steps for inverse. Switch x with y, solve for y. So I just solve this equation for y. I need y by itself. That's what the quiz on Friday was about, if you weren't here. That's what we did. Okay. And here we divide by 3 to get rid of this 3. And we're done. That's the inverse function. Okay. We can give it a title. The official symbol for inverse is that. But there's nothing you can do with that. So it just stays like that. Okay. All right. We need 2 more, huh? Both are the graphing. Let's see if we can get them down. What was the first one I skipped? 13? Where are you? Okay. This one's sketch. Let's do this one first. Well, they're both sketch. What's the difference in 13 and 18? Is there a difference?
13 doesn't have a graph to sketch on.
Oh, okay, so let's do this one then. So these are both y equals. Okay, they're just 2 equations. The easy one is y equals -5. You just go to -5 on the y. 1, 2, 3, 4, 5, and you draw a line like this. That's y equals -5 with no restriction. But they have a restriction. They say, hey buddy, but not the whole thing, just x greater than 1. Okay, so x greater than 1 is, there's x greater than 1 right here, that way. Not the whole thing, just from 1 that way. And since it's not equal to 1, I put an open dot right there. Okay, now this one. At 1, you could, if you have trouble graphing, make your little table. We've done that a lot. And plug in 0, -1, -2, stuff like that, okay? Which I'll do that just to show you. Let's plug in a 0. 3 times 0 is 0. 0 minus 1, -1. There's your first dot. Okay, then we plug in -1. -1 times -3 is 3. 3 minus 1, 2. -1, 2. That's a straight line, by the way. So if you have 2 points.
Please pardon this interruption. If you are in the AC parking lot this afternoon, we need all cars moved out as soon as after the bell as possible. Floats will be pulling in quickly. We don't want any cars hit. Please move all cars out of the AC parking lot after the bell as quickly.
Oh, my car's over there. I forgot. Oh, right here. Hey guys, this is the last part. Just notice the closed dot, open dot. Closed dot came because of the equal sign. Okay, that covers solve but one problem.